Hey there. Today we're going to learn about equivalent fractions and how to find and write equivalent fractions. So equivalent fractions are two fractions or two different fractions that have the same amount or represent the same value, but they will usually have different denominators and different numerators. So in this example here, I have two circles that have been cut into fractional pieces. The orange circle, you can see, has been cut into two pieces, and one piece has been shaded. So I would say that this fraction is 1/2. For my other model over here, I see that this circle has been cut into 1, 2, 3, 4, 5, 6 pieces, and 3 of the pieces have been shaded in, giving me a fraction of 3/6. Now, these two fractions have different numerators and different denominators, but we can see that they actually represent the exact same amount. In fact, if I took this piece and stacked it on top of my other pieces over here, you can see that that is the exact same amount. 1/2 and 3/6 are both equal to each other, and we would call them equivalent fractions. Now, how did I get from 1/2 to 3/6? Well, I had to change my numerator and I had to change my denominator. But the trick is that I have to change them in the same way. To get from 1 to 3, I multiplied 1 by 3. And to get from 2 to 6, I multiplied 2 by 3 as well. So that's how I would find an equivalent fraction. I would multiply the numerator and the denominator by the same number. And the reason that works is because 3/3 would really equal 1/2. And 1/2, if you multiply 1 by anything, you don't actually change the value of that fraction. So in this case, I multiplied 1/2 by 3/3, which changed my numbers, but since 3/3 is really equal to 1, I didn't change the value of 1/2 to 3/6. Look at another couple examples. If I have the fraction 3/5, and I want to come up with a few equivalent fractions that are equal to 3/5. Well, again, I'm simply going to multiply the numerator and the denominator by the same number. I can multiply it by 2/2. 3 times 2 would give me 6. 5 times 2 would give me 10. So I could say that 6/10 is equal or equivalent to 3/5. I could also multiply it by 3/3, same one that we did the last problem. 3 times 3 gives me 9. 5 times 3 gives me 15. So I could say that 9/15 is also equivalent to 3/5. I don't have to go straight in order. I can multiply by larger numbers as well, as long as it's the same and as long as I'm doing it to both the top and the bottom. In this case, 3 times 10 is 30, and 5 times 10 is 50. So I could say that 3/5 is also equivalent to 30/50. Now, all of these fractions here are equal to 3/5, but they're also equivalent to each other. So all of these fractions represent the same amount. Let's look at one more kind of just a neat trick on if I had to come up with several equivalent fractions for, let's say, a fraction like 5/6. If I wanted to write several equivalent fractions, all I could do is list the multiples of 5 and list the multiples of 6 in order, and I would end up with equivalent fractions on each. So the multiples of 5 start at 5, followed by 10, 15, 20, 25, and 30. And the multiples of 6 start with 6, 12, 18, 24, 30, and 36. So just by listing these multiples, I have actually created equivalent fractions that are all equivalent to 5/6. 10/12 I multiplied by 2, 5 and 6. For 15/18 I multiplied by 3 over 3. For 20/24 I multiplied by 4 over 4. For 25/30 I multiplied by 5 over 5. And for 30/36 I multiplied by 6 over 6. Again, not changing the value of any of these fractions, since each fraction that I multiplied it by is actually equivalent to one whole. That is how I can write equivalent fractions.